morning, everyone. Today we are going to start with the multimedia networking. One more topic that is known as your protocols for real-time conversational applications. So we are going to see RTP today, and in the next class we are going to see the SIP. So moving towards the slide, first of all, you have to understand what do you mean by RTP. That is nothing but that is known as your real-time protocol. Okay, so real time protocol, what actually it does, and how we are going to find out, like on what basis we can have these real time transport protocols and all. So you know that it is an internet protocol, because as the name specifies you it as a protocol, so definitely it is an internet protocol. And also it will specify you some of the way of programs where you are going to manage the real-time transmission of multimedia data values, that is nothing but your audio or video data values. And also you can transmit all these data values over any kind of your network services. It can be your unicast, it can be your multicast, it can be your broadcast. Okay, so you can transfer this kind of audio or video multimedia data over any of the network services. And one more thing also, I have already told you about IETF. Okay, I hope you have remembered that. IETF, what is the full form of that? Internet Engineering Task Force. So what it will do, it will just request for some of the comments. Okay, what is that? RFC. Can you see my slide? I have mentioned over here RFC 3550. What is the full form of RFC? That is nothing but request for comments. Okay, request for comments. So here if you want to request any of the comments, you have to use the code as 3550. And also why RTP is used for this RFC, you can say that this RTP is designed only for this IETF audio video transports. Okay, it is useful only for this audio video transport, which also it like supports for your video conferencing. If you want to have with multiple destinations or multiple peoples, that kind of things it is going to provide you the applications. Okay, that's the reason this is also known as your internet telephony. And remember one more thing, that here this RTP, it will be giving you the real time delivery of multimedia data, that you have to remember. It does not give the real time delivery of multimedia data, because if it gives the real time delivery of multimedia data, then it has to be encapsulated with your TCP. But as the RTP packets has been encapsulated with your UDP segments, that's the reason the real time delivery of data packets you cannot guess. Fine. So that is the reason it is very dependent on your network characteristics, whatever the networks we are utilizing. It can be unicast, it can be multicast, it can be anything. Okay, and also it used to manage all the data whenever it will reach from your source to destination side. Then it has to manage all the variety of data with the best effort, or you can say best effort of data values, because always we used to read that the data whatever we are transforming, they will have one kind of your packet structure which will carry the audio and video data, or you can say multimedia data. So when this kind of packet structures has been organized, and they have, when they are moving from one place to another place, that time what will happen is it has to it has to transmit in such a way, or it has to encapsulate all the header files in such a way that it should reach over there. So our focus will always be to find out the best effort or best performance out of that. Okay, and also one more thing here I want to highlight, that you can see here RTP packet provides payload type identifications. What is that payload type? You know, everywhere TCP UDP we have the structure of them, right? TCP structure segment is there, UDP structure segment is there. Similarly, in your RTP segment, what happens is it will have the payload type. Okay, it will identify the payload, and also it will have the packet sequence numberings. Okay, so which is packet number, sequenced which number it moves from one place to another place. All these things has been organized, and also they have given the time stamping. The time stamping is nothing but they will have within the time period to reach from your source to destination side. Okay, and also this RTP, what it will do actually, you know that it runs from your all the end system in the sense it will run in your source and destination side. And also you know that this one will, as it runs in between the end system, then definitely it will combine the data transport. Okay, what is that? That will be a, with a protocol. Fine, it will be, it is like what it will do, it will just have, or it will just monitor that in between your end systems all the data delivery happening or not. And also as we are using unicast and multicast network, so it has to monitor over your large multicast, it has to monitor on your large multicast that large multicast that the packets has been delivered properly or not. Okay, so monitoring system, like it happens in between your sender side and in your receiver side to detect that, to detect if there is any packet loss happened or not, or if suppose if any packet loss happened, then it has to compensate for any kind of your delay jitter. That is the reason both the protocols whatever is working in between your transport layer or network layer, on network layer, they have to find out that if there is any kind of your protocol, any kind of your packet loss, then it has to be compensated with your delay jitter. So in this way we are achieving the interoperability, which is nothing but your like video conferencing or VoIP applications on over this RTP it has to run, and all these things has to run together. So that is the main work of your RTP, which may comes for your 8 marks of question. So it's not over. We'll move to the next one. Here you can see, I already told you, this RTP runs over your UDP, and also it provides the interface of your transport layer and the network layer. So now here what we are going to do is we will have the RTP libraries which will provide the transport layer interface. Okay, and this transport layer interface extends from your UDP, and if it is extends from your UDP, we should have the port numbers, the IP address. See, this is the RTP. Okay, so how this one is working out in our, sorry, this is our OSI layers, how it is working. So this is our transport layer. So in our transport layer, the RTP library will be present with the UDP, and also it has to carry your port numbers, IP address, payload identifications, packet sequence numbering, and all the time stamping. I have already made you to understand what is the meaning of each. So here they are going to have the informations in your RTP header. Okay, the informations will be in your RTP header, which is already encapsulated with your UDP and also with all variety of your port numbers and IP addresses. So what will happen, the receiver, what he will do, he has to reconstruct all the data values, and also he has to describe how you are going to have the coding and encoding process if all the data or bit streams has been passed through, or if it has been packetized. Okay, so as per the rule here, the UDP will run, or it will use this datagram protocol will use this RTP library, and then it will transfer all the packets from one place to another place. So now let's take it one example. Suppose if I want to send 64 kbps of PCM, which is an encoded voice over your RTP, how I'm going to send that? I have to use my application layer because it deals with that. So this here the application will collect all the encoded chunks. Okay, first what it will do, it will encode all the data chunks. So in, I told you that it takes 20 milliseconds of time for each data chunk. So for every 20 milliseconds of data chunk, it has to go for 160 bytes of data, right? For each 20 milliseconds time period, 160 bytes of data has to be present inside your chunk. So what are the things we are transferring now? The audio chunk plus your RTP header value from where the RTP packet has to be encapsulated with your UDP segment. So the two things we are going to transfer. The first one will be your audio chunk, whatever the values are there. Then the next one will be your RTP plus UDP segments. Okay. Here what will happen, this RTP header, what it will do, it will just indicate you that which kind of your audio in type of your audio encoding is present inside your each of the packet. So that what will happen, it can change your encoding during the conference time. Whenever it is passing, it can change it. So it will contain all varieties of your sequence number and your timestamps. That has to be remembered. And also you know that I have already explained you the sequence number. Sequence number means what? Whenever you want to use to find out the to detect the lost packets, okay, that time you have to go through your sequence number, because the acknowledgement will receive with your sequence number itself. Okay. Then what about your, here we have used the timestamp, payload identification. What is that payload identification? What it will do in that payload identification? It has to describe the specific media encoding so that anything can be changed if it has been adopted with any variation of your bandwidth or frame indications. Okay. Or if you want to start, go for the starting of the frame, so end to end collections and all it's going to have. And along with that, it will also have your source identification, source IP address, port address. So all the the synchronization process, this timestamp, everything. So what will happen, these all are known as your RTP components. Okay. If you will put all together, so everything is known as your RTP components. So through these RTP components, we have to move the packets, or you can say that the multimedia data from source to destination side. So now how we are going to include the quality of service, that is known as your QoS, inside your RTP. So what will happen here? We know that this quality of service is nothing but it is a kind of your feedback which we have to include whenever there will be a number of packet lost, or how the round trip time has been organized, or you can say that how the jitter delay is there. Okay, so the source has to adjust all these variety of data rates accordingly. So that time what will happen, we have to calculate our QoS, that is quality of service, it's providing the best effort or not. So that time we have to use our you can say, like we have to use the mechanism where we can have the timely data delivery. If we are not having the timely data delivery, then we cannot guarantee on our quality of service, because if there is no data delivery, then the feedback definitely it won't be good. So that is the reason we have to find out always what will be the data delivery with the time stamp, and if it is not there, then there will be no guarantee of your QoS. And also this RTP encapsulation, which encapsulated with your UDP values, it will be always inside the end system. So if you have any intermediate routers there, then it won't provide the best effort. Okay, because there will be a special effort which will, when the RTP packets will arrive to your destination side, so that will be your timely manner things. Okay, so it will enable all the synchronization process in the intermedia, and it will try to separate all these transmitted audio and video streams. So that is the reason it won't provide that much of a special effort towards your RTP packets. So here you can see your RTP header. Okay, so what is your RTP header? This is a structure of your RTP header. Already we have discussed, we will have one payload identification time which will carry the 7 bits of data. Okay, and if any sender changes any encoding during a call, then the sender has to inform these things to your receiver side. So we have some of the payload identification named like 0, 3, 7, 26, 31, and 33. So if you have 0, then you can understand that it is a PCM connectivity and with the 64 kbps data values. If it is a 3, then it is a GCM connectivity and 13 kbps. So similarly, we have given some of the payload types. So it will indicate that which type of encoding is currently being used. Okay, if the sender wants to change this call, during the call anything encoding values, then the sender has to inform to the receiver so that the transmission will be successful. Now the next one is your sequence number. Already you know the sequence number. What is the meaning of sequence number? Whenever we will send any packets, each packet has to be acknowledged with some of the sequence number. So if any packets will get lost or something happens, then we will come to know that okay, that sequence number has not been received, in the sense some packet lost is there. So it will helpful for the RTP packets to send from your one side to another side, and also we can restore the packet sequence, and it carries 16 bits of data. Similarly, timestamp is there, and what is your timestamp? This timestamp is nothing but it carries your 32-bit long data bits, okay, and it will helpful for you to sample all the data RTP data packets, so that whenever we will send for audio, whenever we will send, or we will just give the any time period, so within that sampling period the data or the audio has to reach inside your receiver end. And also if there will be a like application, when if any application generates any kind of your chunks, okay, then what will happen, it can encode 160 samples, okay, then that time the timestamp will increase to 160 for each RTP packet whenever the source will be activated. Fine. So depends on your chunk value, your timestamp will get increased. And if suppose the times, this kind of timestamp has to continue, it will continue in a constant rate, okay, if the source is inactive, because it has to finish this 160 encoded samples. So that is the job profile of your timestamp. So next one is, what is that? Synchronization source ID. That also carries your 32 bits of data. What it will do, it will just identify you that the source of RTP stream, and also each stream in your RTP session, how distinctly it is like your like synchronization source ID. So it is going to identify all the source of your RTP stream. So then the next one will be your miscellaneous fields, which carry some of the data values or error data fields, or if anything is there, it's going to carry over there. So this is the structure of your RTP header. So now you can see here the RTSP or RTP programming assignment, how we are going to do the RTSP or RTP programs. So how we are going to do, the first thing is the server has to encapsulate with your stored video frames. So if it has been encapsulated with the stored video frames, then it can be transferred like your RTP packets. And if we have any video frame, then we have to add the RTP header into that, and then we have to create the UDP segments, and then we have to send these UDP segments towards your UDP sockets. And then what will happen, whenever any packet things we are going to send, it has to carry the sequence number and the timestamps, okay, then only the all these things the client side will provide. Then we have to write the client side program, and we have to issue any of the commands. If you want to play or pause, that commands we are going to give. Then the server side of your RTSP is going to provide you all these data things. So these all are the way to write the program in your client side and in your server side. So now, what do you mean by real-time control protocol? There is one more like a concept is there, which is known as your real-time control protocol. So what will happen in this is, suppose you have any conjunction with your RTP. Okay, so that time what you are going to do, like if you have any participant in your RTP sessions which you want to send the RTCP control to all the packets and all, so that time how you are going to do, so that is a major role will be played here. And also here what will happen, this kind of your packets it will send to your all of the variety of your participants. Okay, so the major role of this one will be, it will have one packet structure, okay, which has to be defined under your RFC 3550, whatever I already told you. So then what it will do, it will have one control information about all these RTP sessions. So it will have the authority to send to deliver deliver the packets or multimedia data, but it will not transport any media data by itself. Okay, so the primary focus of your RTCP will be like on your quality of service, how quality of service you are going to provide when there will be a media distributions. Okay, so you have to periodically you have to check all the transmitted packets and the round trip delay time and the packet delay variations. All these things you have to check it out over your streaming multimedia sessions. Okay, then only it can carry or control all your quality of service parameters, because if you can't deliver the packets properly, then there will be a loss of packets, then where the feedback will be it will be not under the control. So to increase your performance and to increase your bandwidth and everything, you should have the feedback and quality of service properly. So that is nothing but about your real time control protocol. Whenever you are going to send the packets, you have to send the number of packets, how many number of packets lost, how many number of packets sent, how many number of packets has been received, and what will be your delay jitter. So all these things has to be carried out inside your RTCP. So if I told you already, we have to send all these things on your multicast or unicast or broadcast network services. So here the RTCP provides your multicast. So here you can see the sender is there, this is a network service, and this side it is a receivers. So what will happen here, each RTP session, a single multicast address has to be there. And also all RTP and RTCP packets, they have to belong with your multicast address. Okay, multicast in the sense you can send the packets from your from source to many destinations, multi destinations. So that is known as your a multicast address. Unicast in the sense only particular one server and one receiver will be, one client will be there. Okay, so that is the difference between your unicast and multicast address. So here you are going to send all the RTP and RTCP packets on your multicast address. So it can have one sender, but there will be a multiple addresses where the data can be sent. Okay, so here another thing also will be there, it will have the different port numbers, distinct port numbers, and it is going to distinguish the packets, and the RTCP will help to RTP to distinguish the port numbers and to send over your RTCP traffic. So whenever we are sending the packets over your RTCP traffic, we have to just measure that it will be a limit traffic, so that the number of conference participants will get increased. Okay, so if each participant will reduce your RTCP traffic, and it will increase the conference participants. So here you can see the diagram, RTP and RTCP is moving now. So from here also RTCP and RTCP packets will move to the networks. So there will be a RTCP packet types. Thus there will be a receiver report packets, there will be a sender report packets, there will be a source description packets. Okay, so whenever we will have the receiver report packets, that time the fraction of your packets will get lost and the last sequence number will be achieved. And also we will have some inter-arrival jitter, or you can say that delay jitter. Fine, that will be occurred inside your receiver report packets. What will happen inside your sender report packets? Sender report packets, there will be a stream of your RTP packets which will have the current time and the number of packets sent and the number of bytes sent. Okay, and inside your source description packets, there will be an email address when the sender and sender's name will be associated with your RTP stream, and then they have to map with your SSRC, and then they have to send with the user or host name. So it provides the the mapping in between your SSRC and also with the host name. So this is the packet types inside your RTCP. So now what is happening inside your RTCP? The stream synchronization. So how we are going to do the synchronization inside your RTCP? So here what will happen is Suppose if you want to send the multimedia data streams within a RTP session, or if you want to have the video conferencing, then each sender has to generate one RTP stream of video, okay, or you can say one stream of your audio. So there will be given the timestamps within that RTP sessions, and these RTP packets will tie to the video and audio sampling clocks, okay. So whenever we'll send it, they will not be tied with a wall clock time. That you have to remember, we have to give the sampling clock time period over there. So whenever it will go through your RTCP sender, then the report packet will contain the like recently generated all the packets which is already initiated or associated with your RTP stream. So that's the reason it will have the timestamp of RTP packets, okay. Then the receiver will use this association of synchronization playout of your audio and video, and the audio and video can play in the receiver end properly. So this is known as your RTCP synchronization method, which used over your RTP stream of data packets. So this is about your RTCP synchronization method. Now, what is how, if we are sending the data packets in such a way, then how we are going to have the RTCP bandwidth and scaling. So here the RTCP will attempt all the limits of your traffic, like to 5% of session of bandwidth and all. Then what will happen? Like some example, suppose one sender is there sending video at 2 Mbps of data. So that time the RTCP has to attempt within the limit period, okay, and it has the traffic will be 100 kbps. So it will give you 75% of rate to receivers, and the remaining 25% to your sender side. So 75 kbps has to be given to your receiver side, and then all the receivers will get the RTCP traffic, okay, at 75 kbps, right? That has to be there. So 75 kbps has to be equally distributed among your R receivers. Then all the sender will get the RTCP traffic with 25 kbps, because I told you na 75% will go for your receiver. So 75% has gone for your receiver, another 25 kbps whatever will be there, it will go for your sender side. So if it will go like this, then only RTCP can attempt the limit of your traffic of 5% of your session bandwidth. Then what will happen? Then the participant has to determine that RTCP packet transmission period, and then the packet size, the average packet size, which has been already given over your sessions. Then it has to divide by your allocated rate. Then here only allocated rate. So then only what will happen? Then we can calculate our bandwidth which is occurring inside your RTCP. So that was all about your RTP. Now we have moved towards your SIP, that is known as your session initiation protocol. So what do you mean by session initiation protocol? So it is quite simple, and we have to because this is also can come for your 8 marks of question. So where what and we all know that this SIP is nothing but it is a signaling protocol, okay. It will give you the signals, and where it will give over the VoIP, okay, and it will like define all the message or in between. It has to maintain all the messages in between the sender to receiver side. Fine. So first it has to set up the call. Then it needs some of the like if I'll give you one example. So telephone calls, you can see, right? So in telephone calls, what will happen? First it has to set up the call. Then it has to find out all the details of two telephone talking, who all are they. Then the call has to set up and the phone enters into a data transfer phase, right? So whenever the call will be there by using these protocols and all, then it will move the voice packets between your two phone callers, right? So in this world, the VoIP is not using. We have gone for the video conferencing, that is known as your VoIP. So now this SIP is a call setup protocol which will operate on your application layer, okay, and also it will be very flexible protocol because it will go into the depth, and it will just find out the modulations and everything. It will be a very clean and clear because it will use the general purpose way to set all the real-time multimedia sessions, okay, in between the sender and receivers. Suppose if I want to give one simple example also, whenever the SIP will set up this telephonic call, that time video and audio will have the multicast meetings, okay, because it is a single server and multiple clients. So it will have the multicast meetings, and then it will send the message, instant message, right? So here what we are learning, that SIP is a term where we can have the telephone calls, but video conferencing is a term where we have used on the multicast network services. So the people can be identified by their names or email address, because video conferencing, through video conferencing, you have gone through your name or email address, right? You have logged into that. So it is quite different from your like SIP. So it will just reach with your callers, those who wants to join with the calls and all with the IP devices. So that is a simple term of your SIP. So how SIP services are there? So we will have the mechanism, already I told you. First we have to set up the call, then for caller to let know that who wants to establish the call, then the caller and caller can agree on media types like encoding, then end the call, okay. Whenever it will go on, then they have to determine the current IP address, because it has to map with your mnemonic identifiers, okay. It has identifier address of your IP address. So they have to determine the current IP address. And how they are going for the call management, they have to add the media files, multimedia files during the call. Then they can change this by using the codec in the sense coder and encoder streams. Then they have to invite others, and then they can transfer the call or they can have the whole call. So these all are some of these SIP services which has been provided by your SIP. So you can see here the example. Now Alice is there having one IP address, Bob is there having one IP address. So I'm inviting Bob. Of which address? This is my IP address. So this is my IP4 address I have given. This is my address which I am giving, and this is my multimedia audio profile, right? So for the port number I have just sent it. So it will have inside my Bob's terminal rings. So now 200, we know that 200 means okay, the connection is like established, right? It will indicate his port number and IP address, and then it will prefer the like encoding part, then it will send to the particular port number. Then the SIP messages can send over your acknowledgement. If it is having the TCP or UDP, it's going to send over. Then what will happen, we can send our audio or multimedia audio or video files over that, through which the it will create the SIP port number, and it will transfer the audio and video in between the client and server, or in between the Alice and Bob. So in this way, we have to set up the call to know that how the IP address are working out. So this is the example of your SIP. So if you want to setting up a call, like how you are going to do. So if you want to, I told you codec, right? So coder and encoder negotiations. Suppose Bob doesn't want to have this encoding part and all. So what he can reply, instead of replying with the 200 okay, it can say that 606 not. So it means that he is not interested to have the establishment with the Alice. Then it can accept the reply and list out the encoders things and all. Then Alice can send the new invitee message, those who are advertising that like we want to have the establishment, because there will be a n number of clients, those who wants to have a transmission of packets. So they can have the different encoder process, and through which they are going to join. And suppose one more case, it can be like it can reject the call in between. So the Bob can reject the call by replying, I'm busy, I'm gone, payments required, or something like that. So that time the media has to send this kind of like reject message over your RTP stream, or you can utilize some of the protocols. So these are the some way of transferring the call from one place to another place. Here you can see another example of SIB. Here we have written this one, whatever in the diagrammatic way we have seen, the same thing we have written by using the HTTP message syntax. So what is the message first? the inviting will be towards this mail id where sip message with the version name 2.0. Then via what we are sending? Sip version name udp. This is the sender address. Okay, so then from whom it is coming from? This is the mail id to this is the mail id. Caller id is this one. Content type will be application. Then content length will be 885. Then you are sending here ip4 ip address. I have used the version 4, and then I have this address to where I'm sender address. Then here you can see the audio message. Okay, so this is the like, and also this sdp means session description protocols. Okay, or it is a application protocol. So it will have a unique caller id, and through which the bob's id has been intermediated, and the alice wants to send a message by using this http message syntax. So it is very easy to remember. It is not difficult to remember. Just you once, if you will go through this, you can, it will be easy for you to remember. So now how we are going for the name translation or user locations. Suppose one caller wants to call the callee. So how the caller name or email address, how they will find out? So first they have to generate the caller's names and email address. Then it has to generate the IP address with the current host name. Okay, if you want to go for the DHCP protocol, you can attach that also. We'll have the different IP devices like your PC, smartphones, and any of the car devices. What will be the result of this? The result can be based on your time of day. It can be your work. It can be your home place, anything. So the caller don't want where you are, like in at home or office or anywhere, because the location doesn't matter. Okay, only the name is name matters. So the status of caller can be sent by a voicemail, that if you are already talking with someone or something like that. So that time it will give you the beep sound, and it can give you the message like you are busy. So that time the location doesn't matter, only the name and the message matters a lot. So now how we are going to have the SIP registrar. So here we will have the SIP server, that is known as your registrar. When the Bob wants to send any of the SIP client, then client sends the SIP register message to your Bob's registrar's server. So how the register message will be looks like? You can see the registrar. This is the domain name with the version name. You are sending through SIP message, version name UTP. This is the address from and to. Then it expires within this 3600 time period. This is a timestamp. So in this way, the registrar can send a message over your SIP server. And if you have the SIP proxy, how you are going to work out? That is again one more SIP server, but it will be a like a temporary SIP server. So here suppose Ali sends any invite message to her proxy server, then it will contain the address SIP. Then what will happen? The proxy will be responsible for routing all these SIP message to the callee, and also it will have the multiple proxies. So whenever the Bob sends any kind of your response back to your same set of your SIP proxies, that time it will return the SIP response to the Alice, because it will contain the Bob's address. Then it can analog with your local DNS server with your TCP setup. So in this way, the SIP proxy will have one SIP server with multiple addresses and all, and they are going to contain all the, they will be responsible for routing all the SIP messages. Okay, so here you can see the SIP example. Okay, so here this person calls to this person. So first what we are going to do, the first setup will be, this is the IP address where the Jim sends invite message to here SIP proxy. Okay, next what we are going to do, we have to send this proxy message, we have to forward it to your poly SIP registrar. It is a server. Then here what will happen, the poly server will return a redirect message that yes, that it should try to connect with this SIP, because you can see this UCOM whatever has written here, it has been, this is a registrar. So next what will happen, he will send directly the request to this UCOM registrar server. So whenever you are sending anything, the server name has to be mentioned over here. Here it is has written there two SIP proxy, so we have sent here. Then two poly register we have sent here. Poly register told that don't send to me, send to this URCOM's SIP register, then we have sent here. Then URCOM register forwarding the invite to your running with your SIP client, because normally you want to send the data packets from here to here. So in this way we have sent the packets from media or audio files from your sender side to your receiver side. Then it will send you the acknowledgement back, which has gone through this the responses, and it has been reached over your sender side. So you have to draw this kind of diagram whenever the question being asked with an example. So here the data flows will be in between your sender to receiver side. Okay, so if you want to go for the comparison stage with your H.323, then here H.323 is another signaling protocol for your real-time interactive multimedia. Okay, it will be complete and it will be integrated with many of the protocols, where it will have some video conferencing signals, registration process, admission control, transport, or codec and all. So it will have a single SIP components which will be associated with your RTP, and also it will not mandate it. Okay, it can be combined with other protocols also. So it will be away from your I2U telephony. It will just comes from your IETF, which already we have described, already discussed before. It will have the concept of your HTTP, and also like it can use the KISS principle, that is keep it simple stupid principle. So it uses all this variety of your protocols to find, to have the comparison in between your SIP, which is very important. So you have to remember all these things, and with this your RTP and SIP concept gets over. I hope you people understood this. The question can come in any way, so there will be 8 marks of question on the same topic. So please go through the slide once again to have a clear idea. Thank you.